In this episode,
it's exciting to see all these new products coming to market, I think, as a potential customer.
1000%.
People are hungry to see data, or certainly certain people are.
This also means you don't need a buffer tank with one of our installations.
Modbus, BACnet, OpenTherm, eBus, CAN bus, one other. MBus.
We're approaching it in different ways, I guess, aren't we?
How accurate is accurate enough?
Heating's not very exciting. Most people don't think about it until something breaks.
I have a Samsung heat pump that is new but doesn't have Wi-Fi connection.
A manufacturer will choose what they want to give you.
You don't always have to have super accurate monitoring.
The cost is just reduced to zero.
Accuracy obviously comes at a cost.
There's nothing more important than data.
Welcome to another episode of Homeowners Q&A. I'm your host Mars, and today we're exploring monitoring solutions for heat pumps that can help homeowners keep track of their system's efficiency, performance, and running costs. To be honest, today's panel is absolutely insane. We've assembled some incredible guests, and joining us today we have Henri Casteleyn from Havenwise, Trystan Lea from OpenEnergyMonitor, Jamie Elliot from Homely, George Reburn from Planet Devices, Luke Hodgkinson from Adia, and Trevor Sweetnam from Good Energy. Welcome everybody. But before we get started, we'd like to say a huge thank you to today's sponsor, Good Energy. Starting out as a renewable energy supplier 25 years ago, Good Energy has grown to offer heat pump, solar and battery installations, smart energy tariffs and electric vehicle charging solutions. Good Energy is also the only B Corp home energy supplier in the UK, proving their commitment to people and the planet. And quality is also guaranteed because Good Energy only installs premium hardware that's built to last and that's backed by long-term warranties. And there are no third parties, just directly employed, highly qualified and accredited teams that treat your home with respect. If you'd like to find out more, head over to goodenergy.co.uk. When we set out on our heat pump journey 6 years ago, the guy that came and commissioned our system went through our control panel, and being a bit of a geek, I was really watching what he was doing, and he was just going through pages and pages of data. There was graphs, there were logs, there was data absolutely everywhere, which kind of excited me because I thought, wow, this is going to be really cool because I'll be able to delve into all of this data that my heat pump is actually generating to see what I can actually do, and I'll be able to keep tabs on all of that. So when I asked him, will I be able to get access to it? He says, yes, no problem. It's all going to be on our website. You'll be able to log in. And when I did, all I had access to was the COP of our hot water and the COP of our heating system, which was really, really kind of weird because there was just so much data that I actually saw on these logs and screens. So from a geeky perspective, it's been really exciting for me to see that home monitoring is coming along by leaps and bounds in the last 2 years. And all of you guys that are on this actual call are very heavily involved in all of that. So the objective of today's session is to find out what your product does and what benefit that actually has for homeowners. Let's start with you, Jamie. Can you tell us a little bit about Homely?
So we're a UK-based technology company specialising in the optimisation of heat pumps. In total, we're about a team of around 25 people, which includes PhD mathematicians, software developers, user experience. And we've been around now for coming up for 6 years in totality and gone through a number of different stages. Where we are today is that we're currently serving thousands of customers every day who trust Homely to optimise their heat pump, to make sure we deliver comfort in the best way possible, but also in the most optimal way as well, in terms of efficiency and cost. So we do that by responding to lots of different data points to help modulate that heat pump. So we modulate the heat pump so we're continually running it at different flow rates based on a number of different factors. So whether that's understanding about how your home gains heat and loses heat, whether it's about what's going on in the outside world, in terms of weather, solar gains coming into the property, but also the energy system. So we respond to dynamic tariffs. We've also done a lot of work around responding to grid frequencies, etc. So we've got quite a comprehensive product set, and we try and make it really, really easy for end customers. So you get what you want from your heat pump at the lowest cost possible, but it isn't something you have to necessarily engage with lots. But clearly, there is lots of data in the background, and we know people are hungry to see data, or certainly certain people are, which is obviously another challenge for us to try and get that balance right.
Trystan, can you tell us a little bit about OpenEnergyMonitor?
The name that a lot of people will know us from will be HeatPumpMonitor. HeatPumpMonitor.org. We run a website. There's an online leaderboard of heat pumps, people sharing data from heat pumps publicly. And this is a resource that both homeowners and engineers can use to understand, how well heat pumps work. As a business, we sell a heat pump monitoring kit, which is a fully sort of independent monitoring package. So it's like a heat meter, electric meter, class 1 electric, class 2 heat metering, and that provides this high quality level of data for this kind of sharing of data on Heat Pump Monitor.
Luke, could you tell us a little bit about Adia?
We're a pretty young company. We've been around for about a year and a half now. We're 8 people. And we take a slightly different approach. We're not really a straightforward smart thermostat. Heating is not very exciting. Most people don't think about it until something breaks. That's shown by the fact that over half of the 1.7 million boiler sales in the UK each year are last minute replacements. The problem with decarbonising heating though, it's that getting a heat pump installed today is really costly. It can take months and causes a lot of disruption. So our solution is to make that installation much more straightforward whilst also providing that comfort afterwards. We have a smart plumbing interface, which is connected to the heat pump during the installation and then connects to the home on the other side, which allows you to install a heat pump without changing your pipework and radiators in the home, which means that the installation can take less than 3 days and can be comparable in cost to a gas boiler with the current bus grant in place. We will then guarantee that your home is warm and that your energy bills will go down. And once the heat pump's installed, Adia can actually measure the room by room heat loss of your house. And that will allow us to make recommendations for which upgrades will impact your bills the most and actually give you an ROI calculation there. We can provide room by room temperature control as well, so we can make sure that you can have good comfort. But we're really about flipping that customer journey and making sure that homeowners can decarbonize their heating first and then make the fabric changes to their home later when it's convenient.
George, can you tell us a little bit about Planet Devices?
We're slightly different, I think, to a lot of the panelists on today's show. We're sort of coming at it from a different perspective. We believe that homeowners should be supported, and we should be encouraging the relationship between the installer and the homeowner. So we support homeowners indirectly via installers. We're providing the tools for installers to provide a better service to their customers, which are the homeowners. So we sort of sit in the background and provide a suite of facilities for heat pumps, solar, EV, batteries, EV chargers. It's sort of a one-size-fits-all type approach. And these tools allow installers to make better decisions, to optimize their technologies across multiple manufacturers and models on the fly. We also provide live monitoring, which is real-time data to show COPs using calculated values to give the installer the best chance at providing the homeowner the most comfort and making the best decisions. They need all of that information at their fingertips. And who is better positioned than the installer and better informed than the installer to make decisions? We also provide that facility for installers to pass on this information to the homeowners should they be interested, because Mars, as you've said, not everybody's as geeky as you perhaps, and really all they're interested in, as Luke said, heating's not massively interesting. As long as they're warm and their shower is hot, that's kind of all really the majority of people care about. We're trying to provide that visibility and that transparency without relying on manufacturers' cloud platforms, which you never know really the validity of that data. So a bit like Trystan, we're really keen to give that independent, transparent view because it's so important. There's nothing more important than data.
And Henry, do you want to tell us a little bit about Havenwise?
Yeah, absolutely, Mars. Thank you. Havenwise is also a relatively young business. We write software only for heat pumps. That's what we do. We don't do any hardware. We write software only. And our goal really is to make heat pumps as easy and as affordable as possible for homeowners and as cost effective and fast to install for installers as possible. What we do really is 2 things. There's the monitoring element, which is what we are going to talk mainly about today. We extract all the data from the heat pump. We make it available to homeowners and installers. Then there's a second part, which is the optimal control, which is where we make sure people are comfortable, but at the lowest possible electricity bills, taking into account a ton of parameters, including the electricity tariffs and weather forecasts.
So Trevor, you are our neutral party today. You kind of live in the world of energy data. Could you just give us a quick rundown as to why this is important to be able to keep tabs on heating data, on energy monitoring when it comes to homeowners from an installer's perspective, as you are with Good Energy?
Thanks, Mars. Yeah, sure. So yeah, as you say, we're sort of the neutral party in the room where, I guess as an installer, we're sort of the consumer of that data, or one of the consumers of that data. Since the very beginning, we've installed all our heat pumps with monitoring kit alongside. I think that was very important for us, to make sure heat pumps are connected, make sure we had visibility, and then I guess we also have an eye into the future at things like demand response and flexibility and so on. I mean, the guys have done a great job of describing the sort of data you get back from heat pumps. I think there's sort of 3 main use cases we have for that data. So the first is kind of closing the loop on our design process and our install process. So when we install a heat pump, we monitor for a few weeks to make sure everything looks okay. And then on an ongoing basis, we track performance, we tie that back to the design, tie that back to the house, and we close the loop with our install team. Then we also, obviously, for our customers, it's quite a different experience heating your house with a heat pump in a lot of ways. You're quite used to a boiler where you come home, you flick it on, and you get a big burst of heat. Obviously, heat pumps don't work like that. And so we use the data as part of like an educational process for customers. So, we can analyze their usage patterns, look at their temperatures, give them tips around setting up their schedule in the best way possible, setting their hot water in the best way possible, just to try and up their performance. And then the last thing, as I mentioned, is sort of forward looking. So we think form part of the solution to greening the grid and dealing with peaks and troughs in demand and supply. So it was important for us basically to from the beginning, build a stock of connected heat pumps. It's exciting to see all these new products coming to market, I think, as a customer, a potential customer.
1000%. Do you need help understanding your heat pump? Then pick up a copy of From Zero to Heat Pump Hero, an essential guide offering practical advice and basic instructions for new heat pump owners to maximize system efficiency. Available in print and on Kindle, link in the description. So Jamie, I'm going to bring this back round to you. So before we actually recorded this episode, I went onto our forums and I was able to have a quick look at questions that could come up with regards to monitoring. And there's actually one here that kind of brings Homely together with HeatPumpMonitor. Vaillant units do particularly well on HeatPumpMonitor, but Homely does not offer Vaillant support apparently, nor does it do NIBE or Mitsubishi. So my question is, what is the compatibility? And we'll start with Homely. What is your compatibility with different heat pump brands, and what kind of kit is involved to be installed in order to make your product work?
For Homely, we have a device in the home, which is our hub that effectively connects the heat pump to our cloud, and that's a local device. And we have that because it gives us just control around user experience, ultimately, about how do we keep these heat pumps online all the time. Because as we know, with any device in the house, they can drop off. We also know that people change their broadband router, everything falls over. What do they go around and connect? They connect the phones, they connect the laptops, they connect the TVs. Do they go and collect the heat pump straight away? Possibly not. But we've learned over time that that's a really effective way of us controlling the user experience. So we have that hub in the house, but we then connect to the heat pump through something called Modbus, which is a simple 2-cable installation into the heat pump. We do that because it's a really effective way of making sure that we can provide consistency across all the heat pump brands. And it means that we can deliver a consistent experience across those brands in terms of how we control and optimize those heat pumps. When you look at the market, in terms of compatibility with Modbus, I was out at a conference in Berlin just a couple of weeks ago, and there was talk about interoperability and all the different ways you can connect to heat pumps. And Modbus is the single most common way that you can connect to a heat pump. There's lots of different ways you can do it, but Modbus is the most consistent. And what we're seeing is more and more new brands come to market, support Modbus effectively out of the box. So in terms of brands we connect with right now, we connect with probably around 70% of the addressable market in the UK that are currently being installed. It's always kind of changing. So obviously some of the brands that had a big market position like now, when new brands coming in, means that changes. So we've got Samsung, LG, Daikin, Midea, Clavette, EBAC, Riello, and many others as well. We're doing some work with Bodge and Ideal and stuff. So lots of brands covered. I think we're up to about 12, 15 brands now. But there's some that don't support Modbus, or there's things in there that mean that we have to look at different routes. So Vaillant is one of those. We'd love to work with Vaillant. We know Vaillant very well. We speak with Vaillant often, but they use something called eBus, which is a different way of doing it. They have gateways and things in the place, and it just means that we can't directly connect through Modbus right now. There are alternatives, but we choose not to do that because there's pros and cons of that. So we know that they didn't have an API, but that's not our chosen route for delivering our service for our reasons, and there's always give and take for why those things are. NIBE, their latest versions actually can support Modbus, so that is something we could do. We prioritize our integrations based on demand. If you're an eBay user and are interested in Homely, contact us, let us know the demand's there. We'll prioritise and do the work. Mitsubishi, again, is one that I guess I can say is in the pipeline. So that will be with us soon in terms of what we're doing there.
So Trystan, when it comes to HeatPumpMonitor, you've already kind of briefly given us a rundown of the kind of kit that's involved. Are there any compatibility issues with regards to your offering?
By having like an independent heat meter and electric meter, it sort of gets around that kind of compatibility issue. But I guess the thing to say is that we are focused on monitoring. We're not doing control of heat pumps, and so we don't actually need to link into the kind of control system. That's the advantage of using something like Modbus, is that you can actually access all the control side as well. There's sort of pros and cons to having separate heat meter and electrometer. Obviously that's an expense. If you link in like what Homely and Planet Device is doing, I believe, where you're linking in more on the Modbus side, you have that advantage of control, and you can pull out monitoring data from the heat pumps themselves. There's quite a variation in how accurate that data is. That doesn't always matter. You don't always have to have super accurate monitoring. Taking one step back with HeatPumpMonitor, initially the sort of spark to create it came from reading about these studies that have been done on heat pumps over the years, like the Energy Saving Trust trials and more recently electrification of heat. And they all take this sort of independent monitoring approach with, a class 2 heat meter and so on. We were seeing the results come out of those studies. The results were not quite as high, often below 3, somewhere between 2.6 and 2.9 SCOP. But we were seeing, much better results from the engineers that we were working with. SCOPs around 4 were quite normal. Part of what we've been trying to do is actually just prove with the best data that we can that this is possible. The highest performing heat pump has on HeatPumpMonitor has a SPF or SCOP of 5, but it's sort of a different aim, I feel, from say what you guys are doing at Homely or Planet Device in a sense that we're not trying to do the control side, and so we're approaching it in different ways, I guess, aren't we?
Luke, your offering is again completely different to I think that anybody else on this actual panel offers. So could you just walk us through your compatibility and what kind of kit is involved to get your system up and running?
Like Homely, we connect over Modbus. The reason that we want to do that is that if there's any internet connectivity issues, being able to maintain a schedule and being able to control the heat pump during offline times is still really important, and delivering hot water. Our system can maintain those schedules offline even though there's no connectivity. And that's why we chose Modbus at the end of the day. We've been around a lot less time than Homely. We're still kind of working through some of those brands, but we're currently working with Samsung, Midea, Clivet, and Riello as well. Like Homely, when we have demand for others, we'll be adding those, and they will all be Modbus at least at the beginning. In terms of installation, there's 3 main parts to our kit. We've got our hub, which is the plumbing interface that I mentioned, which is actually plumbed in between the heat pump and the home. So it's very simple to install. You have essentially 2 pipes coming from the heat pump, the flow and the return, and then you plumb it into the existing central heating circuit in the home, and then the hot water circuit, and there's a joint return. This means that essentially to have a heat pump replace your gas boiler, that's all the plumbing that's necessary. Our unit will take over. We then have a smart radiator valve. If you have TRVs on your radiators, it will just slot on top of that. But we use them in a different way. As I'm so sure people here will know, using smart TRVs with heat pumps is a little bit dangerous. You can starve a system of volume, which can cause it to cycle. So our valves don't operate like normal TRVs. We use them to balance the flow throughout the home to make sure that we're delivering the right amount of heat to each room based on the demand of the homeowner, whilst always ensuring there's volume for the heat pump to access if it needs it. This also means you don't need a buffer tank with one of our installations, because we provide that access to that volume to the heat pump.
So George, same question to you. Planet Devices, what's the kit and what's the compatibility?
Compatibility is always the bottleneck, really, in our industry. As Jamie has said, to onboard all of these different bits of kit is always a challenge. We have a piece of kit. It's very small, very simple, no buttons or touchscreens or anything, and it goes into the home and connects into the appliance, whether that is a heat pump or an EV charger or a PV inverter. Our kit was designed to be compatible with as much as possible from the beginning. We're compatible with NIBE. It's not publicly available yet. We're looking to roll that out in the next couple of weeks. Mitsubishi, we're fully compatible with the Ecodan, FTC4, FTC5, and FTC6. Vaillant, as Jamie mentioned, is the big bugbear for most homeowners because they use something called eBus, which is not the same as Modbus. It is slightly more in-depth and difficult to get the data out of. But thankfully, our kit is compatible. So we're compatible with Modbus, BACnet, OpenTherm, eBus, CAN bus, one other, MBus as well. So the kit from the start of our journey was designed and built to be compatible with all of these technologies, because we knew that along the road we would come across a new product that would come out that wouldn't use Modbus, for example. We wanted to be able to provide monitoring for that kit. Once you get over that hurdle of the actual physical connection to the appliance, grabbing all of the data is the next step. So we are taking that data from that little box that I've just shown you, we're taking that data directly from the appliance and we're normalizing it and standardizing it to be something which people are familiar with. So we're familiarizing the data. You'll have two different manufacturers that will call flow and return slightly different things in their data capture. And so we are taking that data and making sure that it's presented in a way that is familiar to the homeowner, to the user, in this case, the installer, so that it becomes a cross-platform, cross-technology, cross-manufacturer normalized way to describe things. So our kit sits in the home. It's forgotten about, really. You bolt it to the wall, you plug it in with the necessary connections, and you don't think about it again. Everything from that point is in our portal offering, which is called Sphere, and from there you can view the data, you can control the appliance, in this case perhaps a heat pump, so you can set values as well as read them. And so for an installer, that's incredibly useful on the fly to be able to diagnose faults, optimize performance, all the good stuff that you'd expect and want as a homeowner. But we go a little bit further than just the optimization of the appliance. So because we have this visibility and it is live data, we can apply machine learning to the optimization process of what Planet devices are doing. And so we can take a live snapshot of the hundreds of heat pumps that are in your area, and we can take a real-time assessment of what best optimizations are applied, which allows us to sort of go a little step further than optimization and be able to apply real-time changes on the fly, which is what we're trying to encourage here, which is that relationship between the installer and the homeowner, which we think is just so incredibly important.
So Henry, you guys are completely software driven. Are there compatibility issues with what you guys are actually trying to implement?
To some extent. I think the key difference is we don't need any kit. So we don't need a hardware box to be installed. We don't need a Modbus adapter. We don't need, those upfront costs for the homeowner or that installation time for the installer. We've chosen that approach because it has really, really meaningful benefits for a homeowner, because the cost is just reduced to zero upfront. It has benefits for the installer because they don't now need to get a ton of extra hardware in the van that they need to source from a distributor. They don't need to train their installers to install it, and they don't lose installation time on site. And then for us as a company, it also is beneficial because software just moves much faster than hardware, so we can be very quick and agile. In terms of compatibility, at the moment we do support Vaillant, we do support Mitsubishi, we support Samsung, we support Daikin, and we are continuously building out compatibility further. There's really no limits to compatibility beyond the fact that a manufacturer needs an API. We believe that is where the industry is going to. That is our choice, and that is how we approach things. I think Jamie mentioned it before. There's trade-offs. There's always trade-offs, and there's choices. But that's the direction we took as a company.
I just had a question for Henry, which is that I assume that you would need a network adapter for most of those heat pumps to be able to connect, so a separate piece of kit to be able to connect it to the cloud.
Most heat pumps get installed with the Wi-Fi adapter today. Historically, that hasn't been the case, but today a lot of heat pumps get installed out of the box with a Wi-Fi adapter. There's regulation that kind of requires heat pumps to be internet connected from, I think, 25 or 26 onwards, which means, from a certain moment onwards, that is just going to be how heat pumps are installed.
But you wouldn't need that with a Homely or with some of the other kits that we're talking about here, because they would provide that internet connectivity as well. I just want to make sure we're comparing apples to apples.
I was going to ask a very similar question to Luke there. I have a Samsung heat pump that is new but doesn't have Wi-Fi connection. If I wanted to connect it to the Wi-Fi, it will be £120 adapter. It's an additional component, I think.
So Trevor, over to you. What kind of thought process do you guys have to put into the kind of systems that you go with? And obviously there's more and more options that are now going to be available on the market. What is it that you guys are going to be leaning towards to try and give homeowners that best visibility and access to data?
I thought the points the guy's been making around accuracy were quite interesting. Like he certainly, as Trystan said, you see quite a variation in terms of the energy, the quality of the energy monitoring on heat pumps. Have to say, from our point of view, we've actually used the OpenEnergyMonitor, put it alongside some of the other monitoring kit we use as a sort of a baseline. And yeah, we've seen that variation there. Media are our main brand that we install at the moment, and actually their internal monitoring kit is quite good. Alongside the accuracy, there's sort of volume or the range of data points that you can get out. So probably for homeowners, the performance is the main bit of interest, energy in, energy out. We kind of focus on, I guess, temperatures, flow return temperatures, compressor speed, flow rates, that sort of thing. So we can use those data feeds to then preempt faults help customers resolve issues on their own without us having to disrupt them or make them be home from work when we're doing a van roll. And then probably the final and very important thing is around price point. So there's obviously an ongoing cost to maintaining connection, storing data, making that available via the web. I guess if we're competing with boilers which generally aren't connected, then that's another additional cost of running a heat pump. So finding the right balance, I think, between quality, depth of data and cost is probably the key thing for us.
Have you got questions about heat pumps and renewables? Then head over to the forums at Renewable Heating Hub for practical advice from thousands of fellow homeowners and heat pump users. So Jamie, with your kit, do you require extra electricity meters and other monitoring equipment to go along with your control box for HomeLead to work?
No, so we don't require it. This summer we launched HomeLead Connect, which is our monitoring platform for installers. So we're giving all the data around the heat pump, what's happening, giving them effectively like a live health check of the heat pump and how it's operating. That enables the installer to obviously proactively serve their customers better, see all the data, reduce revisits, call outs and all those things as well. So ultimately deliver a more cost-effective operation from their perspective, but also improve the customer experience. And so that's again a feature that comes as part of our product. There's no add-ons, it's just a software feature that we now deliver to installers.
So does HomeLead extract the bulk of its data from the Modbus? How accurate is the Modbus data?
I think from an accuracy perspective, I'll probably go back to my technical team, but obviously, we use that and rely on that data a huge amount in terms of operation of the heat pump. We use external data, so we were looking at, I think weather forecasting has been mentioned, but we're also looking at the data that our internal temperature node captures as well. So we do have a hub, but I guess the piece we didn't mention is we have an internal temperature node. So that gives us an internal reference point. We firmly believe in open systems, so we're just looking to know where effectively the room that's used most frequently is where that temperature node would go. It's very small, it's fully remote, and that just tells us what's happening inside the home, and that is our reference point, but also helps us to understand solar gains. So solar gains are really, really powerful in terms of efficiency, because if you can understand the natural heat that's coming through your windows, you can respond better, and obviously that is a big part of how we deliver the results that we do. Going back to that Modbus piece, definitely because the way you're reliant on the heat pump itself in terms of the data it's collecting. So the data that you passed is only as good as what's being collected. So in terms of energy usage and things like that, there's an accuracy of it, but we know when we put a third-party energy monitor on there as well, it will come back with a more granular result. But I guess from what the service we deliver, we get from Modbus is more than sufficient to deliver the service and the optimization that we give to customers.
So Trystan, what I'm beginning to extract from this conversation is that your biggest selling point actually is the fact that you've got these meters that are able to track the flow temperatures and the actual electricity consumption a lot more accurately than maybe perhaps Modbus does. Is there scope in the future for guys like HomeLead, for example, or any of the other guys on this actual panel to potentially plug into you guys to be able to utilize your meters to make their systems even more accurate?
It sounds like, correct me, George, but I guess because you've got an MBUS input, haven't you? So it sounds like you probably have been doing some direct connection to heat meters with that.
To sort of answer Mars's question, for accuracy, it is a very hot topic, and we're sort of a hybrid approach from pure Modbus monitoring and what Trystan is achieving with OpenEnergyMonitor. We're really big fans of what the guys at OpenEnergyMonitor are doing, and the accuracy of the data that they're collecting is going to be bar none. They've got independent temperature sensors which are connected to the inlets and outlets. They've got independent heat meters. That sort of level of metering of energy in, energy out, as Trevor said, is really very high. But we have gone for the hybrid approach between the pure Modbus monitoring, which, as we all know, is provided by manufacturers. If any of the information that the manufacturers are providing is going to be questionable, it's going to be the energy usage. Currently, we provide a CT clamp and a voltmeter, which allows you to independently monitor the energy usage of the appliance. And then we rely on the Modbus data for all of the technical bits and pieces for installers to be able to control and optimize. As you've mentioned, Trystan, the ability for Atmo, which is our piece of kit that I showed you earlier, to talk via MBUS to heat meters is there. We can take the same box, attach it to an existing heat meter in the property, and present that data, which is going to be far more accurate than the current values that Vaillant, for example, will be reporting. And we can plug the two together. There is scope there to sort of bring the two data sets alongside each other for the pursuit of the highest accuracy of data that we can achieve. Yeah, definitely.
Just to give a bit of a kind of context to the kind of variation we're seeing with Vaillant, the difference between what the Vaillant app says and what our monitoring says. There's one in particular that I've been involved with where our monitoring is saying SPF or SCOP of 4.8 over the last 12 months, whereas the Vaillant app says it's been getting a SCOP of 6. We've seen that quite a few times. It's not always the case. Sometimes that, it's bang on, it's really very similar. Sometimes the Vaillant app underreports. How much that actually matters is another question, because if it is saying it's got a SCOP of 6 in the app, then good chance that it is actually working really well for you. You're going to be happy with the running costs and so on. If it was saying it had a SCOP of 3.5 and you were actually getting a SCOP of 4.5, you might think it's working less well than it is. It depends how important that figure is for you, I guess. We've seen sort of similar things on the Samsung Modbus outputs.
I think Trystan makes a really good point. How accurate is accurate enough? If you have a OpenEnergyMonitor SCOP of 4.8 and your app report 5.2, does it matter? Both numbers are really, really good, and it will be a very fantastic outcome for the homeowner. And then I actually had a question for George, which is, why does Planet Device choose to do independent electricity metering, but not independent heat metering? Because what we've seen in terms of the discrepancies are mainly driven by the heat, not by the electricity.
It's a scalability decision. As I said, Trystan's solution, I think, is the best. It tends to be quite expensive. That's mainly because you have to install a heat meter, as we all know, can be quite expensive. We sort of made the decision to keep the costs of our kit down. To be able to apply 100 devices of our devices to 100 heat pumps is better than having one or two very expensive installs. So the price point for homeowners, especially if the installer is putting the price of a monitoring piece of kit on top of their installation fee, is a big deal. The benefit to homeowners is they're still getting that level of service, but it is much, much cheaper to implement across thousands of heat pumps as opposed to tens and 20 and 30 heat pumps. I realized that the particular question that Henri asked was, why do we choose electrical metering as opposed to heat metering? So the electrical metering is really easy to do. It's really, really affordable. Throw a CT clamp around a mains cable, really, really affordable, really scalable, really easy to install, non-intrusive. Whereas installing a heat meter, as we all know, it's a wet install, so it requires a plumber, which can become quite expensive, and the heat meter itself is quite expensive. It comes back to scalability and a price point.
Trevor, I think you wanted to add something?
I think I was just going to echo really the points the guys are making. Accuracy obviously comes at a cost. If we're speaking to homeowners here in particular, I wouldn't want people to get really bogged down in that. The main thing is the monitoring exists and someone's looking at it. It's good enough to see whether, the system's performing well, okay, or good. There's enough data there for your installer to be able to help you to use your system, basically. I think that's the main thing that people should be looking for, not necessarily getting into the nuts and bolts of, is it a COP of 5 or a COP of 5.1.
You're listening to the Renewable Heating Hub Homeowners Q&A, empowering consumers with the knowledge they need to make smarter heating choices. Luke, I think the one thing that's I picked up on your description of your product that's actually coming, the way that you guys are going to be able to try and potentially monitor the flow of the actual radiator circuit in particular. Does that factor in things like the index circuit? Because I think we're a prime example of a very poorly designed system where kind of 80% of our house actually warms quite efficiently. The index circuit always struggles to get to temperature. And you also mentioned that your product would potentially be able to bypass any buffer tanks, which is music to my ears. But what happens in systems that have already got a buffer? Would you guys still be an applicable solution for those homes?
What our system can do when you install an Adia unit is we run essentially a calibration. We have a flow meter within our device. We can control all the valves, and it allows us to use our AI to actually solve for the flow going to each radiator, so that we know that with any combination of valve positions, we know how much flow is going to each one, and that's how we know how much heat we're delivering. We can measure the heat loss and then also control the system to ensure we're delivering enough to each room. What we would obviously do in that situation would be to ensure that that valve is pretty wide open and that we are pinching other valves where possible to drive more flow to the index circuit. That's the first point of call, right? And as long as you've got enough flow going through your pipes, which for most homes I assume you would, it's very rare to actually need 28mm pipes in a home. It's more of a safety measure than a requirement. What we'd then do is can we push enough flow to that room, and is the radiator large enough to heat it? Now, we can always push the flow temperature up to ensure that that room does get to temperature, but that obviously comes with efficiency costs. And that's where we will start to provide recommendations to you. So if we're seeing that this one room requires us to be open all the time and then to pinch down the other radiators and to push the flow temperature up, we'll say to you, well, you might want to look at an intervention here, whether it's a larger radiator or whatever. And we can then use our modeling to show you actually what would the impact of that be, first on your flow temperature and then on the impact on your SCOP and your bills in turn.
Do you need help understanding your heat pump? Then pick up a copy of From Zero to Heat Pump Hero, an essential guide offering practical advice and basic instructions for new heat pump owners to maximize system efficiency. Available in print and on Kindle, link in the description. So Trevor, good energy. Maybe it's time to lose the neutrality hat now. Do you guys use any other platforms that have been mentioned today?
We actually don't. We use a pretty simple platform that we developed in partnership with our heat pump wholesaler, so Freedom Heat Pumps. It's fairly similar to George's product. It's a simple little device that talks to heat pumps over Modbus and sends that data back to the cloud. We generally either use the heat pump controls, or customers have their own preference of connected control that goes alongside that, and so the Freedom device just sends back data from the heat pump to the cloud, and then I guess we're pretty lucky we've got a little data team and the capacity to look at that. Again, I think I come back to the point from earlier. For us is sort of to find the right balance between volume of data, accuracy of data, and cost, so we can serve our customers better.
I think that people absolutely love HeatPumpMonitor, the actual tables and the way that you guys have implemented your systems. The one criticism, if I can actually call it that, against that has been kind of the top of the SCOPs table, in that there are certain people that are just trying to manipulate those figures to try and just edge their way up that table a little bit. So maybe they're sacrificing a little bit of comfort in the home just to get those numbers up.
That term, top of the SCOPs, whoever came up with that.
Yeah, Heat Geek and so on, wasn't it? Definitely hear that criticism a lot, that the SCOP is only one thing to be looking at, and definitely agree with that. It's you have to do a kind of total cost optimize it, total cost of ownership approach, really, where you're looking at unit price of electric, how much you're spending on the install, and the performance, and it's getting all three of those things working well together to give the lowest cost of heat to the homeowner. In a way, is the real goal, isn't it? I've heard this quite a few times, that people are gaming to get right to the top. There's maybe one or two people who've adjusted, go a little bit hotter than they need to when it's mild outside, but they're not actually the systems that are right at the top.
Yeah, there's people that are really data hungry. There's other people that just want to put it in, forget, know that it's doing a good job, have enough confidence it's doing a good job. They look at their bill, they're comfortable with it, best decision they've ever made, and they move on with all the other things in their life. The biggest challenge we have is around making sure we don't make all this sound too complex. Simplicity is there. Equally, if you're one of those people that do want to have that extra insight, there's mechanisms for you to get that. I think that's a great thing for those. But then there's the scaling factor is for us to get into the hundreds of thousands of heat pumps we want to install in the UK to decarbonise heat in the UK. We have to make sure it's also delivered in a very simple, scalable way that meets that majority. And then for the 5-10% maybe that want to see something a little bit different, there's a mechanism for them to do so. And obviously that's a bigger proportion of those heat pump users today because they're the early adopters and first movers.
So you can almost see the adoption curve happening in real time with these customers. Like, you've got the early movers who are like super geeky and into it and want to tweak and optimize everything, and then you've got like more ordinary Joe Stowe people who just want to be warm in their home and know it's all okay. So last winter we sent out this pre-winter report to customers, and we spent a long time like simplifying the data and trying to get like down to 2 or 3 little tips for people, and the feedback was like so telling. Like, half of people were like, oh, that's great, but I want to see this and this and this extra bit of data. And then you've got others who are just, okay, cool, you've made it really simple for me. So try and find the right fit for people, and as you say, Jamie, like, keep it simple and don't make it sound too intimidating at the same time, I think.
We actually interviewed James Clark from Elite Services Group recently, and he said a very interesting comment that he's beginning to find that more and more of their clients that they've had heat pumps for are becoming hobbyists. So it's basically people that have had this put in, and now it's just a geek fest hobby for them. It's they can delve in, they can tweak things, they can manipulate things, which you can't really do with a boiler. So they've spent probably 15 grand on it. So they might as well get some fun and enjoyment out of it as a hobby. So that kind of buys into your point, Trevor. I think maybe you guys are going to have to tweak your reports for your customers this Christmas.
My sort of addition to that was very similar to Trystan's and Jamie's. I think striking the correct balance between someone who just cares that their house is warm and also someone who is interested in the compressor frequency, for example. I think the key point to remember here from a homeowner's perspective is that a manufacturer will choose what they want to give you through their cloud platforms. The frustration that we are finding through our customers is that so much is hidden from them or not presented to them that they would love to see. And it just further cements the importance for independent third-party monitoring presented in a very clear and transparent way, so that rather than not have the data to make the choice whether you're interested or not, having the data to make the choice is far more important. Being locked out from something that's really important to you as a homeowner is not something that's acceptable, really.
So that brings us to the end of our deep dive into the fascinating world of heat pump monitoring. A massive thank you to our panelists Henri, Trystan, Jamie, George, Luke, and Trevor. And we hope this discussion has helped answer any questions that you've had about monitoring. And a big thank you once again to Good Energy for sponsoring today's episode. And as always, thank you to our listeners and viewers for joining us. If you have found this episode helpful, please subscribe, give us a thumbs up, and stay tuned for more insights into making your home warmer, greener, and more efficient. Until next time, stay warm, stay green, stay tuned. Goodbye.